I will share the screen. First of all, does anybody has any question about this morning or about anything? Okay, then first of all, I didn't say it, but as usual, remember to save sometimes the project, your QJS project, because it happens, and actually many times happens that it can crash QJS, so it's much better if we remember to save it. It might ask that it has to replace some older version, but we press OK if it's asking this after the saving of the project. So first of all, I can make a small recap of what we did this morning. We have seen how to install it first, the SWAT model, the SWAT software, and how to start a new project that is done in through QJS environment. And then the first step that has been asked to us is the upload of a DTM, a digital elevation model. Then in our case there was already provided. It was in our folder of the exercise. So after the upload of the digital elevation model, we have seen we have started the delineation of the watershed, starting from the channel and the streams, through also the use of an existing stream network that we already had from other models or from other sources, as you prefer, depending on what do you have. And we have seen how to set, how to put some inlet or outlet shapefile to the model in order to create our subbasin starting from channels and streams. I wanted to show you one thing about the. Okay, let me put visible. Just this was the stream burn-in, the stream network that we had from other sources. As you see, is as a definition that is much let's say precise, higher than the 30 meters of our DM. So when we created the streams and the channels from SWAT, the result is I will show you. It's this one. That it will follow the existing stream that we have set. But of course, since the resolution of the cell is just 30 meters per 30 meters of our DM, it will not consider all the curves of the original shape file, but it will follow most of the path of the rivers. So it's quite, let's say, precise in this sense at following the path, not with the really exact shape, but the final result is quite, I would say, a good result, an optimal result, having this kind of resolution. It will exactly follow our original shape file. So this was one thing that I wanted to say. The other about the creation of these streams and channels, and also of the watershed. Each of the created stream, channel, and subbasin is a shape file, and as a shape file, they all have an attribute table with described the information of each of the reach of the stream and of the subbasin. So just to give a brief look at those information. For example, about the streams, what we can see. If we open the attribute table, we select the streams. We go to the open attribute table to the button here. We see some characteristic of this file that are used in QSWAT and in the SWAT model in general to perform the recalculation, and specifically what it can be seen is the link between the different streams, and also actually there is a link between each stream and the subbasin. So for example, from this attribute table of the streams, we have the field link number, that's the, let's say, the ID of this stream. And we see moreover in this DS link NO that that's the downstream link number, where we see the number of the stream that is downstream of each one. So for example, in this one that I have selected here, the number 7 that is highlighted here on the image, we see that there is a downstream link to a stream that is called 8, that will be actually this one, the one on the outlet. Then there will be also an upstream link number to, in this case, we will have two upstream rivers, two upstream streams, that is in this case 6 and 1. And then we have other information, for example, stream order, that means which are how many, which is the stream order of this stream. We have the length of the streams, in this case in meters, 1,900 meters. Some information like the magnitude, the contribution area of these streams, and some other information like the slope, the average slope along this stream. In this case is 0 because we are in a flat area. Again, something about the length and the contributing area and so on. And the same is for the subbasin. If we go to the subbasin attribute table, we will have a kind of the same description. We just have here the ID in this field and the calculated area, for each subbasin. So it's not as complete as you see, maybe like if you remember the HEC HMS model, because in the HMS model, for each polygon, for each subbasin and stream, you have much more information like the flow path length, average flow path length, the average slope of the subbasin. Here we have some information, not as much as in the HMS, but some basis one. But still is yeah, we have something that we can access through this attribute table. Okay. So after this, that we have created this watershed with this subbasin and these streams. We say, okay, we like this configuration, and we can go on with the model. Okay. At this point, the next step will be the creation of the landscape units, the so-called landscape units. In much part of the model, you will see this LSU that stay indeed for this landscape unit. What are these? These are a further subdivision of the subbasin that's done with this model according to two different type of land of a landscape. Let's say that's mainly if they are in a floodplain or if they are in a upslope. So the model will consider these two landscape in a different way for the calculation. So floodplain and upslope. Is also possible to not apply this consideration in the model, but it is highly suggested to make it in order to have a more well described pattern of our territory. So in general, if we define this when we define this landscape unit, when we later come to define the hydrological response unit, that will be the final unit that will be run in the model. This last one, hydrological response unit, will be defined within each landscape unit. So, and if we also choose to select only some hydrological response unit, that then each landscape unit will be treated separately, so that each landscape unit contain at least one hydrological response unit. Okay, yeah, probably it is not very clear now, but I will explain you later when we treat this hydrological response unit for running the model. So now, until now, to define the landscape unit, we have to go in as usual this delineated watershed tab. We go to the here down on the bottom. There is this create landscape tab, and then there is this create here. Click on create. Okay. This brings up the landscape analysis form. And you can see from here that there are 3 methods of created floodplains. These 3 here, the buffer channels, the dam inversion, and the branch length. So briefly, just to have an idea, an overview of what each of them is considering for the calculation. The buffering channels is a simple method that creates a strip either side of the channel that is a multiple of its width. So there is, as we saw before, the SWAT is providing some width to the river according to some internal calculation. So as we see from the attribute table, we have some like to streams up to attribute table. We had an indication on the width. It's actually not here, but it will be shown actually on the next step. But we have a calculation of the width of the river. And also through these buffer channels, there is an estimation through the area that's draining to each river, which is the width of the floodplain. Instead, for the dam inversion, that is this here, dam inversion involves finding ridges by effectively turning the DTM inside out and finding ridges as they were streams. So the floodplain consists of those points for which the ratio of a 0.8 above the streams to the ridge 8 above the stream is at most the slope position threshold, which is default to 0.1. But you can change this number. But anyway, at this point, it's not much important to know what is exactly doing each of these landscape analysis, but what we will do is try to calculate each of them to make them running and see which is the result on the map, and from that we will have an idea of what it appears to us to better describe the process. That's how we will manage with this analysis. And the last one, that is the branch length, is this one defines ridges points as those for which the length of a flow path for an adjacent point to where the flow path of the 2 points meet exceed a certain threshold that can be set here. And it then uses slope position like the dam inversion. But we will see just from the result. So as I said, since it's not very clear which is the method that will be the best for any particular watershed, the choice need to be made by the user, to the user, and it's probably best made visually from looking at the maps. So we can create at this point a landscape, the landscape unit using all of these methods. For example, we create this. Okay. Through these buffer channels, we set the setting as they are. We go on to create. Okay, and we should have now on the map here on the layer list a new layer here, floodplain by buffer. That is this one. Then we can create, if we open again landscape analysis, the dam inversion. We go on create again. Okay, it should have, we still, okay, we have now also the layer of floodplain by inversion, this one. Again, to landscape analysis, we go to this branch length and we press create again. Okay, I press done now. And we can see, okay, in the layer that, in the map, that we have all these three different floodplains. We can give a look briefly, like the first one, floodplain buffer. Okay, actually we see that quite, let's say, they're thinner among also the others, because it was it considered just the width of the river and with a buffer around this river. So it's okay. Here we see better. It's like in this case is 1 pixel around each branch of the river. While, for example, floodplain by inversion, this one presents much bigger areas for the floodplains, and the same as floodplain by branch. Also, this one is larger than the the one by buffer, similar to the one by inversion. It has some differences inside the calculated area, but I would say they are quite similar. And later we will see, we will choose one of them to run the model, one of these three floodplains. So again, if we go on, we have done this create a landscape. The next tab here in the bottom part of the delineate watershed is the merge of subbasins. This tab is useful mainly when delineation produces very small basins. That can happen when there are small distances between stream junctions. So in the SWAT plus, each user can select and merge the subbasins that you want to merge for any reason. If you have a small basin, or just because you want to obtain one basin starting from all basin. It depends on your project, on your goal. So to do this, we have to click to merge two or more subbasins. We have to click on this select subbasins. Okay, here there is this window that explains how to select basins. Basically, you have to hold the control key, the control key, and click in the subbasin that you want to select. All the subbasins will turn in yellow. So let's say that I want to merge these two subbasins at the upstream part of the map. So I click on control and I select these two subbasins. So as I said, when finished, click save to save your selection, or cancel to abandon. I click on save. Okay. Then there is this merge button. I actually click on merge. Okay, and they are actually merged to sorry, to their basin that's downstream of them. So we now don't have these two small subbasins that I wanted to remove, but they are included in the big one. So a function like this there was also in HMS. If you remember, there is the merge basin. The only difference is that there is not only the merge in the HMS, but there is also the divide subbasin. So starting from one big big basin, we can reduce the number of subbasins with divide. Here we don't have this option. We just have the merge basin. But it well works. So if you need, in this case, to mainly remove the small basin, that's the case of this. But okay, so for the sake of this exercise, actually, we will. I will go back to the configuration that I had before. So, okay, let me go back to the map here. So if I want the configuration of before, so this after this removing of the small subbasin, I have to restart, to rerun this create watershed that I did before. Let me see. Okay, create watershed. It should create again. Okay, yes. We have created again the watershed of before with the... Oh, and now it's not... Okay. It's not showing when I zoom these two sub-basin, but it actually happens sometimes. It's just a matter of visualization. When you do some operation and then go back and retry. Let me see if I can maybe adjust this. If I start from removing the sub-basin from here. If I remove the sub-basin, then I create it again. Okay, at first I will create again also the streams. Okay, we'll create the watershed again with the same option as before. Okay, and here we have again also these two sub-basins that before were not shown properly. Instead, there is another way to select the sub-basin to remove. Again, in this merge sub-basin option, if we go to select sub-basin here, there was the option select small basins. And there, if we click on it, there is this option to merge sub-basins below a certain threshold that can be either by area, this threshold, in hectares in this case, because it was the measure that we have set before in the model, or also as a percentage of a mean area that consider all the sub-bases in our map, and according to the mean, it selected the smallest sub-basin. So, for example, if we say I want to select the sub-basin with that has that has lower percentage area of 5% respect to the mean of all the basin. I write here 5 as was already actually as a default, and I click on select, and we will see which are the basin that has an area lower than the 5% mean. Or in the same way, I can try if I change it with this area option, I can select the area that has the basin that has an area lower than, let's say, okay, I will try to put some numbers, lower than 100 hectare. Let's see if there is something. Okay, yeah, in this case, we have these two sub-basin that has an area lower than 100 hectare, or so on, and you might want to do 200, and again, so you will see also other basin that are selected. So we will go again to this 5 of a percentage of mean area, as was selected before. Okay, before to continue, I have to remove the selection that was made, because otherwise I will see also the selection of before. So I will go in QuakeJS to the option, to the tool, the select features from all layers here. And again, from the select sub-basin for merging tab, I will select again the default of 5% of mean area. And okay, I go on save here. Okay, now if I go on merge, you will see that the subbasin will not merge. That's because you cannot merge a subbasin that has an outlet or an inlet at its exit. And in this case, it was the final basin, so it has the outlet at the end. So in this example, if I click on it, okay, disappear, QGIS, okay, I have it. If I click on the merge button, you will see you cannot merge a subbasin which has an outlet or an inlet. Not merging subbasin with polygon ID value 8. This was the subbasin with ID 8, and they say I cannot merge it. Okay, so in this case, let's say we are fine with this representation, so we can actually continue on the delineation of the watershed. The other option would be the adding of the lake. The third tab is this delineation, add lakes. In our case, we have no lakes to add in the Rabbit example, and it's not a very easy topic, but so now we go on with the next step, but in case if someone is interested or if we have more time in the next part of the presentation, we can also give a look at this. So for this moment, we can go on. We should be okay with the construction of our watershed. We have set all the options that were asked to us. So we click on OK. Okay, and now the delineation of the watershed has been run, and we see it has been completed. We see it because there are these numbers that appeared in the map. That are the numbers that are given to the subbasins. They are actually, this one in the layer subbasin. And
ግን ወደ ኮንቨርት ተደርጎ ለከስተመር እየተሰጠ አይደለም። ሌብልም አለ አጋጣሚዎች
sorry. Okay. I was saying for the subbasin that we have these 5 numbers. Sorry, these numbers of the basin. So there is a column that has been added that before we didn't have, this subbasin column, subbasin field in the attribute table. That's a name that, pay attention, is not the same as the polygon ID that was given before. So here, for this case of giving number to subbasin and rivers is not very clear SWAT. So pay attention at the columns that are created and the number of each subbasin. That in the next step it might be more confusing to this number that are given to the subbasin, but this final one created, this column subbasin, will be the one that we will look, for example, when we will see the visualization of maps. These are the final number given to the subbasin. If I want to see a property of this one, of the last one, I will select the subbasin number 7. That's the new name of the basin. Okay, I will deselect this one. Next step the delineation now is completed, and okay, one moment. And we see it because in the main screen of QSWAT, it's written here next to delineate watershed, done. So we have done this process, and we are ready to the step 2 here. So we can click actually on create HRUs that before was not available. This button to work with. So in general, what is an HRU? Because SWAT Plus uses a subdivision of a landscape unit that we saw before. That's the one that we have created according to the floodplain, if they are in floodplain or in upslope. It uses this subdivision using other information and building our hydrological response unit that are the unit of the main unit that will be used for the model. Because each HRU, each hydrological response unit, is a particular combination of the landscape unit that we have seen before, but also with information like land use, soil, and optionally, if we want to add, a slope range. So we have identified our subbasins and our land use and our, landscape unit. So the next step is to add a land use and soil information to our model. So this will be done in this step 2, create HRUs. We click on this. Okay, I will save before. As you see here, we have this thing written when you save the project file on the disk has been modified externally. Saving the project will overwrite any changes. Do you still want to proceed? Yes, we always want to proceed. It's a normal thing that appears when we want to save this project of QSWAT. I want to now create the unit, and we have this page with these many features these many options to complete for the model to run. Okay, we have this land use and soil part tab, and we see that the next one, the HRU, is not available. If you click on it, we cannot click on it because we have first to finish this one to run this page, and then we can finally go on with the HRU's creation. So with the first step here is the selection of a land use map. Okay, here for some reason, QGIS doesn't show properly the names of all of these options. For example, here I see in my computer laptop select land use, and then there is a starting of a word that's actually a map, select land use map, and select soil map. But yeah, and also here, for example, in table, we don't see clearly land use. This should be land use lookup, and this is a soil lookup. This user soil plant urban. But if you see in the presentation, I have put a screen of this where you clearly see what are the real name, the description of each option. In case you don't see it in your laptop. But again, the first step is to select a land use map. To do this, we click on the button to get the select land use file form. So we go here and the select land use with the 3 points. Again, in our file, in our folder of Robit, I go here on the land use, in the land use folder. There is this folder rob land use new. And again, here you have to select this is a raster file, as in the DM that we have put before. We have to select this hdr.adf. This is the file that will be read by the model. So I select the file. Okay, similarly, I select the soil map. The soil map is also here under Robit. There is a folder called soil, MOWR soil 90. And again, I select the hdr.adf. I click on it. Okay, you may notice from here, from the path described here, that this is land use. Okay, we still we see actually what we have selected, the hdr.adf file. Instead, here in the soil map, the name has changed from hdr.adf to this name qua, to this name here, that is a clip.tif. This is because QSWAT Plus checks to see if the maps, the land use and soil map that we are selecting, if they are substantially bigger than the DEM. If they are much bigger than the DEM, it clips automatically this land use and soil maps according to the DM to avoid that it loads a larger map than necessary. In this case, the land use one, we see that's the same because it has probably a same, let's say, the dimension of the DM, while this one was clipped using the DM file. In the moment when we select this layer, this file here, we can see that they are okay. They are put here on the. We have the layer on the layer list here, land use and soil. We still don't see the result in the map, but that's because we have to go to the next step to see the representation of the map, and I'll show you why. But in general, as I said before, okay, here we have the clip.tif. So when we are preparing this map, this land soil and land use and soil map, okay, first of all, you have to check that their projection matches the DEM projection. In this case, it's always the same as 32,637. So that's okay. But do not worry about clipping precisely on the size of the basin. You can also select a bigger area and it will be automatically clipped. Okay, what's about this land use and soils? Because these maps are just grids that have some numbers. But what we want to do from these maps is that we have to relate these numbers to some land use codes and soil names. Because these maps just have, let's say, numbers like 1, 2, 3, 4, but without indication of what is each number or which is the use and the soil of the layer. So there are these lookup tables, the so-called lookup tables, that are the ones that relate the land use and the soil code to a proper name. These lookup tables are usually CSV files. we can see these lookup tables. Okay. Okay, I will show you in 2 seconds. Okay, the place where we have to select these lookup tables is here in tables. There is land use lookup. And if I go here, there is also a global land use. Okay, example one land use. No, this is some land use that I have put a lookup table that I've put previously from other runs, but these are and I don't know if you might also have this, but these are the two that you have to look at. A global land use that is used in case of FAO maps, or this, in our case of today, this CSV file that described that the tables that we have put here. So if we go to use a CSV file for land use, I will have to select to Robit. Okay, we have all of these CSV files that are the lookup tables. Some of them. In our case, I have to select Robit land underscore land uses CSV. This is our lookup table that for the land use. So I click on it. Okay. So now a table called like this Robit land uses is created also in the project database and appear as a land use table. So next time we will we run the project, it will be available and selected when we start this form. So we only need to read the CSV file once this time. Even if we can, of course, change the CSV type file and import it again. But okay, for the soil again, for the soil lookup table, also here we have FAO soils, global soils, but I will select the use CSV files. I will open it. Here the soils is in is this robit underscore soils dot CSV. I click on it. Okay, it has been done. Next thing that I want to show you is how are done these lookup tables, because they have actually to be created manually by the person that is uploading this land use and soil. Because this is generally done if you have a soil or a land use map. I mean, we will see also later in the case we don't already have a land use as a soil, a specific map, but we want to use the FAO maps or some database that are already existing. But if you have one, because the one of FAO, they are not very, let's say, precise or updated. And so if you have some of your maps that you know that are updated and are done with a more accurate resolution, it's better that you use yours. And in this case, you have to select your to create your land use and soil lookup table. That is done like this. If I open the lookup table that is in our SWAT, again, SWAT plus, example dataset, Robit. I open, for example, the land use lookup table, Robit land use. Okay, this is quite simple. What does this table need to have? It's important to have the word land use in the title in order to be read by the program. Then actually this land use ID are the numbers that are in the raster file of the land use map, and these are the SWAT code that will refer to this number. So if I see a 1 in the map, it means water. If I see a 2 is agriculture. If I see a 3 is a pasture. These are just shorter name that indicates what I'm saying, and 4 stays for a forest. These are the codes that SWAT model is using for its reference for the working of the model. Something similar is done with the other Robit soils, that is the lookup table of soil, where we have okay, the soil, the ID, that is the number in the map, and the correspondent name, the code, these are called SNAM. That's the name of the soil that are found on in the user soil table that the SWAT model is using for a reference for running. So it's not very easy to create this table. You really have to know, to understand what are your initial data and the type of soil that you are using. So it's better if you have it. If you don't, there will be the option to use an existing tables and dataset that I will show you later. But okay, for this case, I will close it. Okay, again, another property that we have to select on this tab of land use and soil is the soil properties, because unless that your project is in the USA, this soil data here, this soil data tab here, in the USA there are some table called table of soil properties of soil data. This is Sergo or StatsGo. But in our case, we will use the table called traditionally user soil. That's typically found in the project database. So it's already here inside the QSWAT. So all the descriptions, all the names that we saw before of the name of land use and soil are described in this user soil table that's already inside the QSWAT. These are the default in the form for database and tables. So there is this under user soil. There is actually this FAO user soil that again is used if you have a FAO table. In this case, we will use a specific one as we did before. We can select also here a table as we done with the lookup table. So here I can select the user soil table that's named should be this one. Robit. It's not layers, not main. It's the Robit underscore user soil. Is this one here. So we select this CSV file. We open it. Okay, we have selected this. And again, Okay, here I was missing a point because it's asking here to select the floodplain map that we have created before using the three different let's say options methods. Here I cannot select the select floodplain map because during the process I recreated the watershed and without selecting again the floodplain map. So I will actually need to go back to the process and create also these maps. So to do that, I need to go back again. Okay. Let me see if I can pause it. I have to go back to the window of delineate watershed. And at this point, I need to go again to the create landscape. I see that there is not this landscape from the layers list. Because I created it at the beginning, but when I changed something, it deleted this landscape. So I go back to create a landscape. I go to buffer channels, I create. Okay, again, create dam inversion, I create. And branch length and create. Okay, should be done. Okay, close it. Here I have again the floodplains in the map. So I should go on. So I have to go again to create HRUs. It's asking me if I want to use as the land use that I set before. I say yes. The soil that I set before, yes. Okay, and then I have to rechange again the land use table because I modified the watershed, so it's asking me again to select the CSV file for the lookup table of land use, that is this one, Robit land use. Soil lookup again, okay, it's already, I can already select it from the list because it is available since I selected it before. For user soil, I select Robit user soil, that's here. Okay, now you see that I have it, the option of a select a floodplain map. That was optional, but now I can click on it as I wanted. So I say we can say that from what we have seen from the maps, for example, we preferred the map called inversion, the one created with by inversion, the floodplain created by inversion. So I click on this. That's the inv flood 0, this last one. Okay, then another thing that we can do is that we can divide these HRUs according to slope bands, so that the model will treat the land, each of the units, also according to the slope. For example, if I want to divide, because for the moment, as we see here, inside these parentheses, between 0 and 9999, so like infinite, it will be all treated in the same way. And the land and the watershed, the subbasin with different slopes are not divided in different types. But for example, let's say that I want to put an intermediate point for the slope, for example, 10% to divide the HRUs. Let's say into those with average slopes in the range between 0 and 10%, and those with average slopes that are above 10%. So to do this, I can click on this set slope bands. I want to add a number. I will add a 10, and I click on Insert. Okay, you see that the slope band box here shows also the intermediate limit that's inserted, this 10. And you can insert as many intermediate points as you wish. So if we want to add also a 20, I can write 20, insert, again a 30, insert. And if I want to remove them, I have to press on clear. Okay, we still have the original one, but in my case, I want to put just 10, and I go to insert, and that has been done. Okay, at this point, we can also define elevation bands if we want. That it is here in this optional part, this elevation band. And these are bands that are used for subbasin at a very high elevation that are affected maybe by snow and ice. So you will have to set them by defining a minimum elevation, so that all of the land over a certain elevation will have these characteristics. And you can actually define how many bands that which are the bands that we are using. That we actually don't want to set in this example because we don't have in our exercise an area that's characterized by snow and ice, so we skip this optional part. Then what we want to select here is the option here to tick. We have to tick on generate full HR shapefile, HRUs shapefile. That it is optional, as it can take some time if there are many HRUs. But at the end, if you intend to visualize HRU outputs after running the model, that is actually what we want to do, then you need to generate this file. So there is no meaning of not ticking this. So you always want to tick this option. Then this read choice is set to now is set to read from maps, and it's currently the only choice. But in future runs, for example, provided that we don't change the watershed delineation, soil and land use files, we will be able to read from a previous run if you run already one time. So we don't have to redo again all of these to complete all of this tab of land use and soil. Okay, now we can create on read to complete this part of land, soil and use. Click on read, it's working. You will see that it has been completed with here we see the count of subbasin. We will have 9. We have our 9 subbasins. The channel were 87. And we will have the count of actually HRU's hydrological response unit that are 521. There is also the possibility that you have a little, even with the same option set, that you have a little difference specifically in this HRU's count, because it might differ a little from laptop to laptop to make some very small calculation, but it's not, I mean, a big deal. It's just a few. It can change starting from very, very little, let's say, error or differences, and it can just affect a small thing, because you see these are all HRUs that are created, and even if some maybe pixel is considered in a little bit different way, it's not a big deal. So after this read of the grids, you will notice that there are a number of changes in the QGIS display. So what we have now more than before. First of all, we can start from the soil bands here on the bottom. Okay, I can remove, sorry, not show all of the other option here, so you can see what is added. Okay. Okay, this is the slope bands map that have been created with the here in this when we set the slope bands. This slope band has been created and allows you to see where the areas of the two slope bands for this project are located. In this case, in white, you will see the area between 0 and 10%, and in black, the area with higher than 10% slope. So we see that has been correctly done, because like the white area is the area more flat, that if we see from the DEM, if we, okay, I'll put them and it shade here. If I put the slope, we'll put the slope over, I will move it here so you see better. Okay, you see that the white part are the one in the flat area, and the black part, for example, on the right part of the screen of the map, where we have a more hilly or closest to mountain area, we have we have more of this black part of area with more than 10% slope. So more than this slope, okay, I'll put it down here again. We have the land use and soil maps that have been now shown on the map. So for the land use, this one, I will show you this one. The land use, here you will see the colors that correspond to each different land use. That was agricultural, pasture, and forest. The value on the map, if we use, I don't know if you know this, there is a nice tool in QGIS that is called value tool. That can be used to easily assess the values on a map. Instead of using that there is this identify features. If you use this identify feature, then you click on in a part of your layer, and you will see, okay, let me go there. the information here on this small table, but it's quite difficult to see in a fast way. There is instead the tool, as I told you, that is called the value tool, that I should have it somewhere. Okay, it's this one called the value tool. You will find in the plugins. If you go to plugins, manage and install plugins, if you look for value tool, I suggest you to install this plugin because it's quite fast forward to look at the values in a file, in a layer using this. So if I click on it, you can see while I'm moving the mouse over the map, you will see here in the value tool that I have here that the column value here is changing while I'm moving. So I see at any time of moving the mouse the value that's continuously updated. So it's quite fast way to see some values. It's a very interesting plugin that maybe is less used than others, but is very useful. Okay, can you hear me? That I lost connection before.
Yes, your voice now is clear.
Okay, great. So I was showing this land use map that have the correspondence between the number, the value that you see here in small on the right, okay, between the value 2, 3, 4 and the label that is given by the lookup table. It's this lookup table that gives this label starting from the value, and the same thing should be with the soil. Okay. Even if with the soil, usually there are some problems in the layer of soil. Yes, indeed, we have also now that we don't see the soil map. That actually, I don't know if you can see that, but it happens sometimes. Depends on your laptop or on but just you cannot see the representation of the map, but this is created and will be used in your model. That depends also if there are many labels, many styles in the soil map. That in this case we have quite some a quite number of different classifications. They will not show here, but don't worry, it will be used on the calculation of the SWAT on the model simulation. So more than this, land use map, soil map that here you cannot see, and the new map that are created, the new layers that have been added are the two full LSUs and full HRUs map. I will show you where they are. Okay, these full LSUs and full HRUs. and they represent actually, okay, if I go here to the full LSU, the LSU, if you remember, they are the sub-basin that are divided between the floodplain and the upslope. While that are the one here in pink, if you can distinguish it from the red of the subbasins. So we have quite a number of landscape units, but if we go then to the full HRUs that are this green, they are much more, because we have not only the distinction between floodplain and upslope, but also the difference in different land use and soil bands. So again, the landscape unit is the region draining into a channel, further divided in floodplain and upslope region. And while the HRUs is the collection of pixels within an LSU that share the same land use, soil, and slope range. Okay, I go down here. For if we go now to the full HRUs table, if we open the attribute table of the HRU, we open it from here. First of all, do you have any question about this part of okay. Okay, can I ask you, do you have any question about this part of land use, soil, or some other question of what I explained, or some information you would like to have? Please tell me if you have something. And also just to understand, if you have created this landscape, land use and soil, does maybe anybody of you has some soil map that is actually shown on the map, or if you've tried it, is like me, that you have just you don't have a representation of soil? Tell me, just yeah, just to know, just to see if you follow me, and if somebody of you has some soil representation. Okay, I can if I go on, I wanted to show you in this full HRUs attribute table, that are the units that will be finally considered by the model, what we can see. Okay, this is the table with the as it was written in the tab. In the tab here, when we read the land use and soil, the count of full HRUs count, they are 521, and that is actually yeah, the number of features as it's written here, features total. If we go in the full HRUs file, they are 521. And we can see this information in the attribute table. So what we can read from it is okay. Let me see it. Okay, this is the first line. This is first of all for sure the subbasin where we are. If we are in one of the subbasin we have created, in the subbasins we have created before, between 1 and 9, they were 9 subbasin. So if I go down and I look for the first line, they are changing between 2, 3, 4, 9, 8, 9. Okay, yes, we have all our 9 subbasins that have some HRUs. Then we see the channel where the water is flowing to. Then we see the landscape, that is the landscape unit that we have set before, if it's a floodplain or an upslope. So we see each of our point of our small HRU at what upslope or floodplain are part. We can see the land use of each of them, the soil. Then we can see the band, the slope band they are referring to. So this is 10, 9, 9, and 9. That means more than 10%. Moreover, when we have the actual area of all of these units and how much respect to its subbasin is in percentage. So, for example, this subbasin, yeah, not this first one because it's 0. That means it's a very small part of the subbasin. But if I select this second, and if I go, okay, I see here from the map that is selected. This subbasin here, this HRU here, that you see that's a composition of different pixels. It's not a unique feature, but is a aggregation of different units that have the same properties. So all of these units, all of these features have the same, in this case, landscape. So this is all upslope. They have the same land use, in this case, agriculture. They have the same soil, which is let's say description. For formal description is LVX, the slope band. So each of these areas is higher than 10%. The total is 6.57. This should be in hectare, this unit. And it represented the 2.8% of this specific subbasin here. Then there is a percentage respect to the landscape unit. Sorry, 2.8% is this area respect to the whole subbasin here, to the whole basin. While respect to the landscape is 17.8 respect to the landscape that is this case was the upslope here, the upslope that I can open from the full LSUs. I can see which is the upslope. That's actually, I see that it's this part. This is the upslope in this area. Okay, then other information are these HRUs that now is without values, but it will be completed on the next step of the HRU creation that will be done next. And this is the link, the number, the ID of the respective channel that is going to flow in. In this case, it was the 0, and each of them is has the name, the number of the channel where is flowing to. So going on, so there is the possibility that channels with a small landscape unit that are mainly short channels, quite short channels, generate some HRUs that contribute strongly to the processing time of SWAT Plus, but make a little difference to the result. And so it's common to merge them. As we can do the merge of the subbasin, we can do also the merge of this landscape, of these channels. There are typically, since usually there are, when you make a watershed and create a subbasin with many channels, there is an automatic process rather than a manual one in order to merge these channels. So to counter this, there is an option to merge short channels into the neighboring ones. By selected, okay, I will go to the option first. Okay, it's here in this part of the land use and soil settings. So there is an option by selecting a threshold, either as a percent or of a subbasin or as an area in hectares, and it will recreate the channel network. So in our case, we will use this slider in the short channel merge group to set the threshold at 2%. So we can go to 2, or we can write also here. That's easier. In the box here, we can write to 2% of the subbasins to remove the very small channel that leads to that correspond to an area of 2% of their subbasin. So I click on 2, and you see here on the bottom there is the selection that has gone immediately to these remerge short channels. So I can click on read again now. And we have seen that the numbers are decreased. The subbasin are all the same. They are the big 9. The channel count has lowered. Before it was, I don't remember if it was like 90, but it went to 72. And the full HRU's count has gone from it was 521, and now is 460. So we have decreased the number of these channels and HRUs in order to make it easier for the calculation of this step, but mainly of the next step, since we don't, it's not necessary to have a calculation for a very small basin of a few pixels, few square meters. So we should see in the map. Okay, the file should have been changed. All the files. Let's see these full HRUs. Okay, no, that's actually a point. Many of the modification that you do, or better, some of the modification that you do while modify these settings time after time will not be shown immediately in your layers here that you have on the map. Even if they are considered in the next step, specifically when you do this, let's say, merging of things, merging and lowering the numbers of features, you will not see immediately on the map and on the layers, because here it appears that they are still the same number as before, but they are actually merged, and the model will be follow this last merge feature that you have selected. So another step that we could do is the adding of ponds and reservoirs that may be added in 3 ways. And you could add the pond reservoir using by adding lake, adding the lake function. That's one option that we are not going to see, but just to know that there is this option. Or by adding pond or reservoir points to the inlet or outlet shapefile in watershed delineation. Because this point will be snapped to channels and will divide the channels in 2. And areas of land use that's called WATR, water, in the adjacent LSU of the upper channel will be allocated to the pond of reservoir automatically. Because the adjacent LSU is the floodplain, if used. Else the normal channels single SAU, and but users are warned of it if there is no water area, and if and if you cannot do this thing, but we will not do it now, just to know that there is this possibility. And you can set this reservoir and ponds with another option, and this one is shown actually here in the by setting the reservoir threshold in this land, soil, and use setting option here, which is the percentage of land use water in the adjacent LSU of each channel that's needed to form a reservoir. For example, I mean, if this is set to 20, if it says to 20 this number, it means that any channel for which land use water is 20% or more of the adjacent LSU will become a reservoir. If the downstream channel is also a reservoir by this method, they are combined into a single reservoir. And the default value is 101, because this will effectively turn this mechanism off. But also this watershed that we have created has no water areas, so no water areas, no reservoir or ponds could be formed, even if we reduce this reservoir threshold to like another number. So we will keep this 101, and we will go on with our example. Okay, let me save one time more. Okay, another thing that we can do before continuing with HRU definition, if you look at the main SWAT window that is, I mean, this one here. If you look here, you see that a new item is available now. That is this select report to view. And it's available and you can choose to view. There are just two reports at this point, which are elevation and the land use and soil reports. And we can open it, one of them as an example. We can open the elevation, for example, elevation. Okay, we see it's a TXT file. This report gives information about how much land is at each elevation, from the lowest to the highest, to the highest, for both the watershed as a whole and for each subbasin. So you see here we have the minimum elevation of our watershed. That's this one. We have a maximum elevation. We have some information like the mean of elevation and also the standard deviation. And you see that at each point, for each elevation, we will see which is the percentage of area that's up of this elevation. So if you want, starting from this, you could create a curve that show you the elevation of the basin, the dimension of the basins at a different elevation. That's okay. That was for the entire watershed. The first, this first here, this first table. If you go down, there is also the option to see at subbasin 1. Okay, here is statistics, so the elevation reported in meters. And we have it for subbasin 1 and subbasin 2, 3, and so on. That was for the elevation report. We can also look at the land use and soil report. And this one lists the land use, soil and slope band areas for each subbasin. And it also lists the area divided into landscape unit if there are in use for each channel reach. So you see some basic information, the number of subbasins, the number of channels, 72, numbers of LSUs. That was the numbers that were obtained by running the previous part of the model, which is the area of the watershed. And here you see for each, okay, among the total area, okay, these are quite interesting information, so that 70% of the watershed stays in a upslope area, while the 30% is in a floodplain. And the same for the land use. We see that a great part of our watershed, 88%, stays in an agricultural area, while 9% is made for pasture, and this 1.79% is with forest. And about the soil, we see that the soil, 96% of the soil is of this type, LVX. That, okay, I don't know exactly what is this, but we have that's the main soil in the area, while just 3% is of this other. While we have this also for the slope, 60% is of small slope, less of 10% degrees, and 39 is greater than 10%. And that's done for all the subbasin and for all the channels in all the subbasins. So we have a very detailed description. of the characteristic of our watershed and a subbasin. And so, as I said, while the soil map doesn't show up in the layer, it will affect the units and the calculation, because if we go to this again in the property table of full HRUs, we see that there is the property of soil, this one here, that's actually been compiled. It's actually been run in the model, so it has been considered. Okay, at this point, we have completed this land use and soil tab, and we will be ready to. We see now this in the other tab, HRUs tab is visible, and we can click on it, and it's possible to go on with this to this phase. And at this point, we will continue for this definition, for this continuing definition of the logical response unit tomorrow, and again with the next step of the training. I want to ask you if you do have any question about these topics, and if you have any doubt that you want to share with me. So please tell me if you have something that you want to share. Otherwise, we will we'll continue tomorrow. Please tell me. Yeah. Yeah, I see that many steps are not, let's say, very easy or maybe understandable, because there is some parts that require some information that maybe they are not quite basic. But to have an idea of what are the requirements and the type of files that are needed, and what will be created step after step, from land use to soil to elevation. This is like a starting point to understand how to use this SWAT model. So
Yes,
let me
Giacomo,
see.
I see some, there is one question.
Okay, I see. Are there any plugins to extract land use and soil? Okay, extract land use and soil. Extract, you mean, I think, to have some land use and soil maps. I mean, if you don't have any maps, if we can download it from some part, because plugins in QGIS actually no. But there is the possibility to download some maps if we go to the link of the download of SWAT that leads to this page. There is also the option, if we go to the tab data, there is this data. If we go on it, and there is this is a global data set. There are some data that can be used in different part of the models. If we go down, there is this land use maps and soil maps. That they are some general maps in the sense that they have a quite they have a resolution. The original one, they say land use of 400 meters. It depends on your use. It might not be sufficient, but in case of maybe large basin, it's still enough for some kind of analysis. So there is the possibility to download these files. They are divided by continent. We have Africa, Australia, Europe, North America, South America. As it said, land use data was constructed from USGS Global Land Cover Characterization. So we actually can use this kind of maps for the land use, and the same is for the soil, that we have this file that, as they say here, they come from FAO. So there is this soil classification, again, divided in continents, Africa, Australia, Europe, North and South America. So actually this is where I would download some easy information about land use and maps. They are not directly on the SWAT model, but it's from their website, so we can easily use them in our model. Okay. Yeah, I see a note, of course. There are a lot of requirement input that, yeah, they are specified in PowerPoint. Yes, it's true. There are some inputs that they are not very immediate to know. Maybe at some point HMS is more, let's say, easy to go. Even without many information at the beginning. Here you can put a lot of inputs. It's not much easy to know how to give the inputs to the model and how to extract these inputs. In this case, there is, for example, this soil and land use that if you start from some tables on a map that you already know, for example, in this exercise, it was already done. But if you have to start from zero, I would say it's quite difficult to create a new layer and lookup table. But what we could do is, as I am saying now, is to download these land use and the soil maps that are, I would say, the main difficult part from their website. And then, because there was also the lookup table part, you don't have to have a lookup table, but you can use this. There is the option global soil that has some direct connection between their internal global lookup table in the SWOT model and the tables they are providing in this for this download. Okay. Yeah. Of course, all will be recorded, and in the presentation, if you follow step by step yeah, indeed the steps of all the passage, from what I explained, it would be it's possible to do this, to start this model from your own, and so at this point, yeah, this time I will continue tomorrow with the next step for the HRU definition and for the part of running of the model, running simulation of the model, and the visualization of some outputs. So yeah, at this point, I think we can conclude here. And thank you everyone for your attention. And
yes, thank you,
yeah.
Giacomi. And I'd like to ask for the participant to don't forget to fill the attendance sheet. And also, I'd like tomorrow to start with the recap of today as as an wrap of all these steps. As you said, it is very informative tool with very detailed steps, but it is interesting to take to go through all these steps. Thank you, Jacob. Thank you, participants, for all. I appreciate your time, your effort. Thank you so much, and hopefully we will meet tomorrow, inshallah.
Thank you all. Bye.
Thank you, Mona. Thank you, Giacomo. Bye.
Thank you, Paolo. Thank you. Goodbye.
See you tomorrow.
Yeah. Inshallah.
Thank you.
Thank you too.
Bye bye.
Thank you. No, thank you. Inshallah. Oh.